Going. So there's no exit ticket for today. The main reason is because, and I'm not going to really get into this, but I taught first period. I went over this. Basically, when I went over this lesson when I was making it, I realized that you guys, we haven't gone over this year. We haven't gone over how to do multiplying by radicals. And so I was like, well, they have to do radicals before they get to imaginary numbers. So I pushed everything into one lesson. And it's not that it was really that difficult. It was just there was a lot going on in one lesson. And then it dawned on me where you actually don't really need radicals to do the imaginary numbers. Actually, the imaginary numbers, I think, are easier than the radicals. Not to mention, I discovered that I will do radicals next chapter. So, punchline is, all the ones that have a radical symbol, like number 1 and number 2, we're not doing those. So, the reason you don't have an exit ticket is because rather than going back and deleting the ones and remaking whatever and making it a huge deal, I just deleted it. I thought that was good enough. Unless you're upset about that, then I can make it for sure. Okay, so it ends up today's lesson won't take super long. There is kind of a lot going on though still. The biggest thing with this, so now we're going over, I guess you could call it division, or call it ratios or fractions. But the biggest thing today is you cannot have a radical in the denominator. Now, obviously, I just said we're taking the radicals out, but remember, the I is a radical. It's the square root of -1. So if you wonder why we can't have a radical in the denominator, the best answer is I have no idea. I can only imagine there was somebody that was picked on a lot by like all the jocks in school, and he was a nerd, and he was like, I'm going to get back at these guys. So he made this to torture all of us for the rest of mathematical time. Is what I'm assuming happened. I haven't looked that up or anything, but I think that's probably it. You can probably write a report on that or something in college. So we can't have an I in the denominator. So we have to figure out how to get rid of these I's in the denominator. So the first step is where it's just a monomial. So if it's a monomial, one term, I guess you could have a binomial on top and on the denominator. That might not be a bad idea. But the way you can get rid of is multiplying by 1. Now the best part of this, and you won't that cool, but I do, is it doesn't change anything. Anytime you want, you can multiply by 1 because it doesn't do anything, doesn't change anything. So we're going to multiply this one by 1. But why does that help us? Well, because we're actually going to multiply by 1, but it's going to be a very clever way to do it. The next clever way to do it is to remember the property that you guys all know, where if you have the same number in the numerator and the denominator, that's 1. So 2 over 10 is if you had a dog on top of a dog, that would be 1. So we're going to multiply by 1. To do it, we're going to multiply by I over I. Now, when we multiply these together, you'll have I times I is I squared, and we all know, hopefully by now, I squared is actually -1, not an I, and so we can do the math from there. So 3 times I is just 3i. 2i times I is 2i squared. It is -1, so it actually ends up being 3i. That is your answer. That's obviously correct. That's great. I don't care if you put that. Sometimes it makes me feel a little bit uncomfortable to put the negative in the denominator. So a lot of times on multiple choice, I'll put the negative out front. So it's -3i over 2. But I couldn't care less where you put that negative. Obviously, as long as you don't put the numerator and the denominator. That's well. But if you want to put them up the numerator, that's out front. That's fine. If you want to leave it, that's okay. All those options are all right. So number 5, same thing. We have 7 over 6i. Same thing. Multiply by I over 7 times I is 7i. 6i times 6i is 6i squared. That gives you 7. Put it as negative over 6. But you do not have to do that extra step. That's fine. Again, this is one of those problems for me personally as a person that took a lot of math in my life, and a lot of math in high school, college. I don't think these problems are terrible. However, I think this is more interesting because if you told me how to get rid of that I in the denominator and you didn't tell me how, I would not be able to come up with that method. So that's why I think it's kind of interesting. But again, the big punchline is that you're ending up with I squared, which is -1. And the other thing is, again, make sure you don't have any i's, any imaginary numbers in your denominator. So go ahead and do number 7 on your own. It shouldn't take too long. Obviously, again, we're going to skip number 6 for right now. Go ahead and do number 7, and I'll put the answer up here in not too long. All right, so my answer's up there, 3i and 5. On those when you have a monomial. Okay, so next thing we're moving on to is if you have a binomial. So you have in the denominator. And the biggest thing we're going to talk about is the conjugate. We just talked about this the other day. The whole thing with the conjugate is that when you multiply together, you end up getting all your imaginary parts to cancel. That's what we want. We don't want any imaginary numbers in the denominator, so we need to multiply all of these by the conjugates. So from last lesson, remember the conjugate, you have the same exact binomial. The only difference is instead of a negative, it's a positive, or vice versa. Now also remember with your conjugate, you have to put it in standard form first, where your real numbers first. I'm not going to make you do that on this lesson at all. Obviously, on a test or a quiz, I might say, what's the conjugate? And yes, then it's fair game. But when I'm giving you a fraction, I want to know if you know how to do the fraction, not all that other little stuff. So today we won't have any that are not in the right order. 5 minus 6i. Also, future alert, you can do the same thing with radicals. We will talk about that next chapter, I believe. Now, before we start, you might be convinced, or you might notice this, and you might think you can do this, and I want to make sure you know that you cannot, especially because I think it's in a couple chapters, maybe it's next quarter. We have some problems that people do this a lot, but if you 2 over 2, you cannot reduce that down, you can't cancel that. If it was 2 multiplied by 5 and 2 multiplied by 3, then you could. If it's multiplying, then you can cancel things like that. But since you're adding and subtracting, you cannot do that. So make sure you're being careful with that. Okay. So, number 8, moving on to number 9. Again, to get rid of this number in the denominator, we want to multiply the top and the bottom. We want to multiply by 1. So I'm going to multiply the bottom by 6 plus 8i, which means you need to multiply the top by 6 plus 8i. Now, one of the reasons I'm trying to repeat myself a lot is multiply by 1, so that both numerator and denominator are the same. These are the problems that a lot of people accidentally do 6 plus 8i, and then 5i. You would think that, you can't do that. You can't, again, that's just putting up a fraction to help you. We're strategically doing one that ends up equaling 1, so we can put it up there. Now, if you're going to multiply this out, you don't have to follow my lead on this and take my recommendation. But I highly recommend. I think it gets really messy because, especially when there's a binomial in the numerator as well, there's a lot of distribution that's going on, and I think it gets to be really messy. So what I always do, and what I will always recommend, I over to the side will put n for numerator, and then I'm going to rewrite this and do my math over here. It's a lot more clear, you have more space, you don't have to worry about all that. So 5i times 6 is 6i. 5i times 8 is 40i squared. I squared is -1. 30i minus 40. And then if you always put it in standard form, you don't have to necessarily. We end up getting -40 plus 30i. Besides that, I put d to do the same thing over here. I know it to work because you're writing stuff down, you're repeating things that you, but I think it's very much worth it for these problems. 6 times 6 is 36. 6 times 8 is positive 4. 6 times 6 is -48. and times negative 8i is negative 64i squared. Now, if you do this correctly, that's negative 64 times negative 1. So you end up with positive 64. The cancel, positive 48, negative 48 are opposites, they cancel. So 100. Now, we're not done yet, but we've done all the hard stuff. I figured out the denominator. The only other thing you have to do is make it into a fraction now. So my numerator is negative 40 plus 30i. My denominator is 100. Here's the thing with this. I'm going to be honest with you. That's not the best answer because you can still reduce this. However, I don't care. I'm going to let you put that. I encourage you even to put that. I've had times where I've students and told them that you need to reduce that. But the problem is this one reduces nicely because when you have a problem like this, a fraction, then all three of these terms you have to reduce by the same thing. So the 40, the 30, and the 100, this one you can reduce them all by 10. The confusing thing comes, this one's 40, but then this one's 7. Where you can reduce two of them, but not the third one, and then you have to make two fractions, or then it just gets complicated. So I decided, you know what? If you know this hard stuff, then you can go over reducing fractions later. That'll be easy stuff you can do once you pre-calculus or something. Last but not least, again, I'm not saying your denominator and do them separately like this, but if you notice, we did all this work for the numerator. And then I did all this work just for the denominator. So fitting that all in this area is not necessarily ideal. All right, go ahead, skip number 10, then we go into number 11. Excuse me. Again, the people miss with this is they do 4 plus 5i, and then in the numerator they 3 minus 2i. No, that's the conjugative numerator. That's fine, but that's not what we're looking for right now. That's not a fraction we want to use. We use one that has the exact same thing on the top and the bottom. That's the whole idea. Same thing as before. My numerator's over here. That's 3 plus 2i. That is 12. 15i. 8i plus 10i squared. So that I squared is negative 1, so that would be negative 10. You combine your like terms, that is 23i. 12. Last but not least, the 12 and 10 can combine, so it's 2 plus 23. That's your numerator. Some time, and I think I mentioned this yesterday with multiplication, where on these problems, now we're just going to do, it's the same, it's multiplication. We're just doing 2 multiplying problems in 1. So again, it's not any more difficult than yesterday. It's just you're doing twice as many problems. Then we have 4 minus 5i times 4 plus 5i. 4 times negative, 4 times positive 5 is positive 20. I squared. So these cancel, positive 20, negative 20, so we have 16 plus 25. 16 plus 25 is 41, I think. So your final answer, 2 plus 23i over 41. That one you can't reduce, but again, I don't actually care if you reduce anyways. But that's your answer for number 11. All right, so go ahead and do number 13 on your own. Once you're done with that, you can work on your worksheet. I'll put the answer up in a second. And remember, there is no exit ticket. So my answer for number 13 is up there.